Hi, this is Mr. Manley. In this video, I'm gonna graph tangent, and as with all of my trigonometric function graphing, I'm gonna set myself up with 5 points. And we're gonna begin with an initial point, and all of the initial points are started by taking the argument. And then for all of them except tangent, we set that argument equal to 0. But for tangent, we're going to set the argument equal to negative pi over 2. And then from there, we're going to solve for theta. So what do I have here? I have negative pi over 2 minus 5 pi over 6. And I still have the over 3 here. So we're going to have to get a common denominator, 3 over 3. So I've got theta over 3 is equal to negative 8 pi over 6. Follow that? I've got a negative 3 minus 5, that's minus 8. Okay? And then let's multiply the 3 to both sides. Oh, and look at that. 3 cancels with a 3 there. And then I've got negative 8 over 2, which is negative 4. So negative 4 pi is my initial point. Negative 4 pi. I'm going to double check and see if that makes sense. You won't know exactly what I'm doing here. But if I go negative 4 pi over 3 plus 5 pi over 6, and then I multiply by 2 over 2, that's negative 8 plus 5 is negative 3 pi over 6, which is negative pi over 2, which is what I need. Okay, so that works. And then for the step, we are going to need the period. The period of tangent and cotangent is pi over the leading coefficient. For everything else, the period is 2 pi. That's for sine, cosine, secant, and cosecant. But for tangent and cotangent, the period is pi over the leading coefficient. And if I have theta over 3, that's 1 over 3 theta. That's equivalent, right? So the leading coefficient is 1/3. And pi over 1 over 3, hopefully you're solid on that and you just know that's 3 pi. So that's our period. And then our step is always going to be the period divided by 4. And that's for everything. We always do period divided by 4 no matter what function we're dealing with. So the step here is 3 pi over 4. Ooh, I wonder how inconvenient that is. But what we'll do with that is, so what I need to do is I need to add the 3 pi over 4 to the negative 4 pi, right? So the thing to do here is going to be to write negative 4 pi with a denominator of 4. So let's do that. So look at the negative 4 pi there. I'm going to take that off, and I'm going to replace it with negative 16 pi over 4, right? So that's equivalent to negative 4 pi, but now I've got a common denominator, and I'm going to start adding these 3 pi over 4s, adding my step of 3 pi over 4. So negative 16 plus 3 is negative 13. Plus 3 is negative 10. Plus 3 is negative 7. Plus 3 is negative 4 pi over 4. All right, so I've got my 5 points, or rather I've got my 4 inputs, right? So I want to get my outputs now. So I'm going to go y of negative 16 pi over 4, and I'll plug in negative 16 pi over 4. I can simplify that now, right? I've done my step work, so I can just call that negative 4 pi over 3, right? So I'm plugging in, so that's negative 4 pi, and I'm plugging that in for theta. So I have negative 4 pi over 3, and that's plus 5 pi over 6. And I already did this. If you notice, I was checking that it made sense earlier, and it did. And what did it? It came out to negative pi over 2, which is what I wanted. So negative 4 pi over 3 plus 5 pi over 6 is negative pi over 2 plus 1. All right, then I'm going to look at at a unit circle, and I'm going to find negative pi over 2 down here with coordinates of 0, negative 1. And what's tangent? Tangent is y over x, right? So tangent of theta is equal to y over x. If I look at that coordinate, y is negative 1 over x is 0. So negative 1 over 0, that's undefined. So none of this other stuff matters. This is undefined. So the entire expression is undefined. All right, so we got our first point. Negative 4 pi, and then undefined, right? Okay, let's plug in our next point, negative 13 pi over 4. So I'm plugging that in for theta. Is there anything convenient I can do here? I guess I can just call it negative 13 pi over 4 over 3 is going to get us to 12, right? Negative 13 pi over 4 over 3 is negative 13 pi over 12 plus, and let's just boost up the denominator here, right? So what am I doing? I'm saying that 5 pi over 6 is equivalent to 10 pi over 12. Fair enough. Plus 1. So that's 2 tangent. All right, so what's going on here? Negative 13 plus 10 is negative 3 pi over 12 plus 1. All right, so that's 2 tangent, and negative 3 pi over 12 is negative pi over 4. Let's look at our unit circle, and we'll go over here to negative pi over 4. What are the coordinates of that point? Coordinates of that point are rad 2 over 2 and negative rad 2 over 2. So I know that's hard to read, but you hear me saying it, right? Rad 2 over 2 and negative rad 2 over 2. So the y over the x is going to be what? Negative 1, right? So I'm going to have 2 times negative 1 plus 1. That's negative 2 plus 1 is negative 1. So we get negative 1 there. All right, and we're ready for the next point. And the next point, y of negative 10 pi over 4. And that's equal to 2. And just trust me, its tangent is 0. You can look at that, plug that in and figure it out, but it's going to be 0. And then I'll go to my unit circle at that point, and the coordinates there are 1, 0, and the y over the x at 1, 0 is a y of 0 over an x of 1. So 0 over 1 is 0. All right, so the tangent of 0 is 0. So this guy here, that's 0 times 2 is 0 plus 1. So that's equal to 1. All right? Okay, so that's how you plug those in, use your unit circle, be able to do that. You want to be able to do that without a calculator and just use a unit circle. And then I'm just going to do the other ones here, and you can do them on your own if you want to check and make sure you know how to do it. All right, so those are the remaining 2 points, and now we are ready to graph. Whenever we're graphing, let's use graph paper. If you're given graph paper, be a little bit wary of that. You might be given graph paper and given a scale, and if you don't like it, throw it out. If we don't like the scale that's given, then let's make our own scale. So I actually don't like what I did here because look at these. These are all negative. So and look at this. I've got all this positive over here and just a little negative. So I want to have more negative. So I'm gonna redo this. Let's move our vertical, our y-axis maybe over here or something like this. Let's see how that works for us. Okay. All right, I'm also noticing something here that, like this is negative 4 pi. So that's negative 4 pi. And this is negative pi. All right. And that makes sense, right? Because that's one cycle. And we said that the period is 3 pi. So what scale do we want to use here? It seems like it'd be pretty convenient. I mean, one thing is to remember our step, okay? So what was our step? Our step was 3 pi over 4. But I don't want to use 3 pi. I don't want to use pi over 4 even for the scale for this. Well, let's just take a look at, what if I went, well, I don't know. Maybe I do want to use pi over 4. What if I went 1, 2, 3, 4? You know, I can just get there. Like that. I think I want to do that. So that's negative pi. But then that's going to be, all right, so think about this. That's going to be 1, 2, 3. And then I'm going to have to go 1, 2, 3. I'm just going to fit. So let's do it. So you have to play around with this scale and think about it. And you may just, if you're not sure what to do, if you can't look ahead and see what to do, you just got to do something. And then maybe after you do it, you go, well, that didn't work, and you have to redo it or work around it somehow. So what do I have here? I have negative 4 is here. So you see that? That's 1, 2, 3, 4. So there's negative 4, and that's undefined. So I'm going to put an asymptote there. And then I've got negative 13 pi over 4. Well, each of these is pi over 4, right? Each grid is pi over 4. So 13 pi over 4, there's 4, 8, 12, 13. So I'm right in that area for 13 pi over 4. So I want to go 13 pi over 4. I haven't done a vertical scale yet. I think I can just go 1 like that. If you notice what I did right there, I said a scale of 1. All right, and let's go. So negative 13 pi over 4, and then it's a little hard to see here because I got this red circle here, but this was negative 1. All right, so 13 pi over 4, negative 1. I'm going to plot that point. And then I'm going to go negative 10 pi over 4 and 1. That's going to be here. That was 4, 8, 9, 10. Negative 10 pi over 4. And then I've got 7 pi over 4, negative 7. So that's negative 4, 1, 2, 3. So that's right there. That's negative 7. And I'm at 3. So negative 7 and then 1, 2, 3 is going to put me up there. And then negative 4 pi over 4, that's negative pi. That's right there. All right? And then we know the shape of tangent. I'm going to go through those points and approach the asymptote. Go through that point, approach the asymptote. And then we need to repeat the cycle. And like the key here, the key now is that these are each 3 apart, right? So I'm going 1, 2, 3, 1, 2, 3, 1, 2, 3, like that. So I'm going to go 3 over and put down my next point, and then I'm going to move up 3 and put my next point. I'm going to move up 3 and put my next point, and I'm going to move up 3, and I just fit my asymptote over here. Go through those points, go through those points. I want to know where this ends up over here. I guess I can tell by the scale, right? So that's 1, 2. So that's 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. So yeah, I'm gonna want to say where that is. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 pi over 4. 8 pi over 4. Is that it? That doesn't sound right. 1, 2, 3, 4, 5, 6, 7, 8. 8 pi over 4. Oh, I miscounted. No, 1, 2, 3. All right, so I seem to be miscounting something here. My points are correct, right? So it's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then I think I'm marking these wrong here, my lattice points here. So my lattice points should be, there's pi, and then 1, 2, 3, 4. So 2 pi. Oh, that's easy. So it went up to 2 pi. Okay. So that, do pay attention to that, because I want to know where these ends of this are, that this is going over to negative 4 pi and this is going up to 2 pi. So I want to do that. And you know, I was trying to count it off there. Another easy way to do it is to just use the period. So if I'm starting at negative 4 pi, and what was the period? The period was 3 pi. So I was going plus 3 pi and then plus 3 pi. And that's 6 plus negative 4 is 2 pi. So that tells me where it's going to as well. Just doing it numerically instead of graphically. Okay? So that is the graph of tangent. And that is really a function unto itself. It's got the negative pi over 2 happening. It does have a period of pi like cotangent has. And then definitely want to know the shape.